First of all, identify where the meter rule or whatever is pivoted. That's number one. Number two, you discover, you identify the clockwise and the anti-clockwise moment or the forces acting on that body. Then you find the moment using those forces to multiply their individual distances, that is their perpendicular distances, from where the force is acting to the pivot. I told you guys that the pivot can be anywhere, it can be at the ends of the meter rule. So whichever force or moment you want to find, you are going to use the force to multiply the distance up to that pivot. Okay, now we also looked at center of gravity. We said that center of gravity simply means that point on a body where the resultant force or the resultant weight of that body will act. The point on a body where its resultant weight will act. And we say that this point is usually at the center of the material. We use a meter rule as an example. We said that if we have a meter rule of 100 centimeters length, its center of gravity will be at the point 50. And this is the point where the resultant weight or resultant mass of this body will act. That point is known as center of gravity. In terms of mass, it is known as center mass. Did you guys understand? Is it clear? What I just said now, is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
All right. If we have a meter rule of 30 cm meter rule, where is the center of gravity?
15 centimeter.
50.
Going to be 15 cm. Then there's something again I want to point out. This is very, very, very important. I said, if this meter rule, for example, now, this meter rule, they will tell you that the mass of this meter rule, for example, if the mass of this meter rule is 20 kg or 20 grams, and the length of this meter rule is 50, the length is 50 cm, that is from here to here is 50. Please, this meter rule, where is the center of gravity? A question.
25.
Where is the center of gravity of this meter rule? The length is 50. Where is the center of gravity?
25, sir.
25, sir.
25. It's going to be 25. I told you before that. Center of gravity will
25.
at the center. Then, what role? How are we now going to place this 20? 20 is the mass of the meter rule. Maybe you can also find 20. It can be given in terms of weight. They say that the resultant mass or the resultant weight of a body will act at its center of gravity. So if you are given the mass of a meter rule and they say that that meter rule is 50 cm, the first thing you will do is to move to that center, which is here is 25. At that 25, you will draw force down. This should represent, this force here, what is it representing? The resultant weight of this meter rule. And what is the weight or what is the mass of this meter rule? Because they gave us in terms of mass. So what is the mass of this meter rule?
20.
20. So here you have 20 grams. Don't forget. Once you see any question that comes with a beam balance of mass, this, or a beam of mass, this, a meter rule of mass, this, a rod of mass. Once they give you the mass, just know that the mass of that rod, the mass of the meter rule, will act at its center mass, or the weight will act as its center of gravity. I hope it is clear.
Yes, sir.
Yes, sir.
So you can see, what is this M representing? You can tell me. This M I circled now. What is it representing?
Mass is representing the mass.
Don't say mass, you are totally wrong. Say mass, you are totally wrong. Please tell me
Center
mass
mass.
of what?
Resultant weight.
Center mass.
No. I want somebody to give me it of it. What is M there?
Force.
Jesus.
Mass of meter rule.
Mass of meter rule. Simple. Simple. What I just said here. Mass of the meter rule. Simple. This meter rule, that once you see the mass at the center, anything that is placed at the center is the same thing as the mass of that body. That body. Because they can say meter rule, they can say pin, they can say metal rod, anything that is straight, that can be balanced. So take note, this M here is the mass of the meter rule, not any other mass, because they can give you mass of the meter rule and they will not tell you another mass is attached here, another mass is attached as so place. So always please remember that if you are given the mass of the meter rule, locate that one first. Draw an arrow down, because weight will always act downward direction. I remember that mass and weight, they are brothers, though they are not the same. That we have a relationship between mass and weight. Weight is simply mass times acceleration due to gravity. Okay. I hope it is clear now, please.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
All right. Now let's look at this question. We have a diagram already. And please, this diagram, excuse me, I need to remove this. There's nothing like that. It's not question. All right, so this is what we have. It says in the diagram above, a rod 50 cm long is of uniform cross section is suspended horizontally on a fulcrum F. They said F for the root P. So please, let's neglect that F. I think we are going to use P instead of F. Fulcrum is the pivot. P. By the action of two forces, you can see the two forces. One of them is 200 Newton and the other one is 40 Newton. If you look at the diagram, 200 Newton is located at 5. While 40 Newton is located at 45. The question says we should find the weight of the rod. You see, the weight or the mass of the rod, anyone. If they give you force and force, that means you are going to fix the weight of the rod. But if it is given in terms of mass, kilogram, that means you are going to attack this as center mass, the mass of the rod. They say we should find the weight of the rod. Look at the rod now. Remember that the weight of the rod is going to act where? Where is the weight of the rod going to act?
On the pivots.
Man.
At the center of the meter.
At the center, which is known as what? The center of gravity. Not going to act at the pivot. Please, people should try and listen. Do you know the reason why I'm stressing that part? Because this is the major part JAMB will focus to ask you your question. That's why I'm focusing on this. When you are given a meter rule. Okay, then next question I want to ask you, what is the length of this meter rule in this question? Is it given?
It's 50. It's 50.
Okay. But without mentioning this 50, once you see 0 and 50 at the end, length is what? 50. And if no length is given to you, if they did not mention length at all, and there is no diagram, and they said uniform meter rule, just know that that meter rule is 100. The standard meter rule used in the lab is 100 cm. Take note of that. I said if they did not mention any length, and they said a uniform meter rule, just know that the meter rule is going to be 100. But they might still say uniform meter rule and they give you the length of that meter rule. Take note. They might say uniform meter rule and they still give you what? The length of that meter rule. They might say that the length of the meter rule is 80. So you know that center of gravity or the center mass is 40. Alright, so let's move on. The pivot is at 15, as you can see. What is the pivot? The mass or the force of 200 Newton is attached at 5. It started from 0 and stopped here, so pay attention. 40 attached at 45. They say we should find the weight of the rod. Where am I going to place the weight of the rod?
On P.
What did I tell you about weight?
At the center of the
meter rule.
What did I please? I want everybody to get this thing. Some people, I don't know. You guys are, some of you are not paying attention. I said the mass. If you can write this thing down, write it down. The mass or the weight of the material used here, the used rod. The mass or the weight of the material will act or will be placed at its center of gravity. And center of gravity simply means center of that body, center of that meter rule, center of that rod. Mass of the rod, they say we should find the weight of the rod. So, and here, we don't have weight of the rod. We have to place it ourselves. Nobody is going to place the weight of the rod for you. You are the one. They might give you the weight of the rod. Just know that you are going to locate it yourself. Even when they have diagram, give you the weight. So what are we going to do here? Where is the weight of the rod going to be? I ask again.
at the center of the ruler.
The center of the rod. And the center, what's the value of the center of this rod?
25 centimeter.
If the full length is 50, it means that the center is 25. So you come to center, you draw a line down. I told you. Call this line W. W means what? The weight of this rod. That is where the weight is at the center of gravity. So once you are through with this, next thing is to move on with your moment. We are giving both distance and the forces. We have 3 forces. 1, 2, 3. Yes, quickly. All road leads to where?
The pivot.
Where is the pivot? You notice that the pivot is at what? 15. So we draw our arrow to the pivot. 40 Newton, clockwise or anti-clockwise?
Clockwise.
Clockwise. Clockwise.
Please. How are we going to do that? Remember, it's acting down. The force is down. It's a weight. Weight you always act down. So it's acting this way to the pivot, you see. Clock is this way. So this is how clock moves from the right. The pivot will always divide the meter rule and clock into 2, right and left. W clockwise or anti-clockwise?
Clockwise.
Anti-clockwise.
Please, you that is saying anti-clockwise, watch, please, watch.
Clockwise.
Please. Clockwise. W is acting this way. Watch what I'm doing. Use your arrow, follow it to the pivot. From that force to the pivot. Look at it, it's acting down. Just follow the arrow, connect it to the pivot. You notice that clock also moves this way when it's going down. This is how the clock moves. The clock moves this way.
Yes, sir. Yes, sir.
And moves this way.
Yes, sir. Yes, sir.
Yes, I understand now.
So this is clockwise. Then 200 Newton. You see the way to where 200 is after the pivot on the left-hand side. Left-hand side this way to the pivot. See this way is it clock?
No size.
Clockwise.
Clockwise.
Anti-clockwise. So right, that summation of clockwise moment is equal to summation of anti-clockwise moment. Then you remember, clockwise moment. What is moment? Force times what? Distance. Abi?
Yes, sir.
So let's start with the clockwise. The first one is 40. What is the force there? Force times distance now for 40. Let's find the moment of 40. What is the force?
40. F is 40.
What is the distance from where to where?
45 to
The distance is from where to where?
From
40 to 15. Sorry. 45 to 15. 45 to 15.
The distance is from where to where?
15 to
45 to 10. 45 to 50.
25. 45 to 25.
Put 250.
45 to 25. So which means you are forgotten our slogan. All to the people.
5 votes.
Please, can you mute now?
You guys should mute your mic.
Please, I'm begging you people, don't forget this our slogan is very important. All road leads to the pivot. So if you stop at 25, 25 is W, not the pivot. The pivot is like the fulcrum, this triangle, the pivot. So it's from 45 to 15. From 45 to 15 is how many? It's not 45 minus 15. How many is it?
Yes, sir. 60.
How many is it going to be? Are you adding it up?
But 5 minus 15.
It's going to be 5 minus 15, which will give us what? 30. So we're getting the moment of first clockwise plus the second clockwise moment, which is what is the first? The second one.
W.
W is the first. So we write W times what is the distance from where to where?
5 to 15. Just 5 minus 15.
It's
10.
from 25 to 15. From 25 to 15 is how many?
10.
Is 10. So it's going to be W times what? 10. I think we are doing the clockwise. Is equal to summation of the anti-clockwise. You have only one anti-clockwise. What is the force for the anti-clockwise?
200 Newton.
200 times the distance. The distance is from where to where?
5 to 15.
How you guys are seeing it?
5 to 15.
It's from 5 to 15. It's acting at 5. 5 to 15, which is how many? 10 again, right?
10.
So you see, we can solve 40 times 30 is going to give us 1,200, right?
Yes, sir.
Plus 10 times W. 10 W. Remember that W is the weight of the rod. Is equal to 200 times 10 is 2,000.
2,000.
Next, we collect like this.
Yes, sir. 10W equals to 2,000.